Morning children, again the same chapter 10 and exercise 10.4 we are solving here. Question number 2, if two equal chords of a circle intersect within the circle, here intersect is the prove that the segments of one chord equal to corresponding segments of the other chord. See, listen here. Segment you have already studied. What is a segment meaning? Chord and the corresponding arc. So, AB and CD are equal chord intersecting at E. What is given here? Two equal chords are intersect within the circle. So, given is chord AB equal to chord CD and both intersecting at E only. At E. Now what we have to prove means corresponding segments are equal. So to prove, see, segments means chord only. See, chord and the corresponding arc. So AB and the arc AB is included. CD and arc CD is included for the segment. So the corresponding segment means above the line you are having AE, right? Then similarly DE for the second chord. So we should prove that AE equal to DE. So we should write AE equal to DE. And similarly one more segment is the BE. BE, the remaining part, is equal to CE. Okay. So how to prove this one means constructions again required. So the same rule we have to take here also. What is that one? Draw OM perpendicular to AB and ON perpendicular to CD. Now we can do the proof now. So by construction we know that OM perpendicular to AB, ON perpendicular to CD. So I can mark here perpendicular sign also because we already completed that diagram. So I'll write here OM perpendicular to AB implies AM equal to BM. Okay. Now ON perpendicular to CD implies DN equal to CN. Okay, together I'll make it equation number 1. Perpendicular from the center of the circle bisects the chord. Now it is given in the question that AB equal to CD. Okay, so half of AB is also equal only, and also we got AM and BM. AB equal to CD means what I can write? AB equal to CD implies half of AB equal to half of CD. Implies again, because we have to prove AE and DE are equal. In this, which part is equal? AM equal to DN. Equation number 2. Okay. Now the proof we can go, because one more criteria is there. What is that one? AB and CD are equal. If the chords are equal, then they are equidistant from the center. That means OM equal to ON also, right? But we can write AB equal to CD implies OM equal to ON. Equation number 3. And what is the reason for this one? Equal chords are equidistant from the center. Equal chords are equidistant from the center. Now I can go for the triangle wise proof. Let us see what one. So 3 steps are there. 3 steps are there. We can, what is the first step? ON perpendicular to perpendicular construction. So we have got AM equal to BM, and we got two chords are equal, AB equal to CD, then half of AB equal to half of CD we are taken. Once again, what is the concept? Equal chords are given means they are equidistant from the center. Now I am taking the triangles. Which are the triangles? Triangle OME and triangle ONE. Angle M equal to angle N equal to 90 degree by construction, right? Now what is the next one? OM equal to ON, equation number 3, that is proved in 3. Now OE equal to OE common. Here if you want you can write a construction is the reason. So triangle OME is congruent to triangle ONE. What is the criteria? One is 90 degree. OE common side we have taken, that is the hypotenuse one side. So it is RHS criteria. Now what we can write here? ME equal to NE by CPCT. Equation number 4. Right? Now what is the concept we are having in mind? That AE equal to DE we have to prove. So in 3 we have written already, in 2 we have written that AM and DN are equal. Now we have written that ME and NE are also equal. So see this one, AM, I'll repeat the question, that is the equation 2 plus 3, 2 plus 4 gives AM plus ME equal to DN plus NE. You can check the left side AM, here also ME. So AM plus ME. Right side is what? DN and NE. I'll put here bracket, okay. So what is the sum of this one? AE. And what is the sum of this one? DE. So we have proved the first part, AE equal to DE. The corresponding segments are equal. So equation number 5 we got. Now AB and CD are equal, right? Because it's equal chords. AB and CD are equal. Now I am subtracting from the equal side. AB minus AE. From CD, what is the equal side? DE. So from the total distance AB, we subtracted AE. So what is remaining? The BE. And from CD, what is subtracted? DE. So what is equal to CE? So 5 and 6, what is the concept we got here? Corresponding segments are equal. Repeat the question if you go for the question. The segments of one chord are equal to. The segments of one chord are equal to the corresponding segments of the other chord. So using 5 and 6, what we can say? We can conclude that segments of one chord equal to corresponding segments of other chord. So I'll repeat the proof. It is a very lengthy one. What is given in the question? AB and CD are equal chords intersecting at E. Then what we have to prove? That the segments of the one chord equal to segments of the other chord. So here it is given that AB and CD are equal. So by construction we have done OM perpendicular to AB, ON perpendicular to CD. So what we can write? AM equal to BM, because perpendicular bisects the chord. Similarly DN equal to CN. Now the chords are equal, so half of the chords are also equal. That means AM equal to BN. I can write BM equal to CN also. Anything if you want, you can write either this side or that side. That's all. So AB equal to CD. One more criteria we are going to use this one. What is that one? The chords are equal means they are equidistant from the center. That means OM and ON are equal. Now you compare these two triangles. 190 degree we got, and hypotenuse are common, and then one more equal side we got. So RHS criteria, these two are congruent. By this, what do you get there? ME equal to NE. Already we have written AM and DN are equal. So we are adding the equations, equation 2 and equation 4. By this we are getting AE and DE are equal. Once we got AE and DE are equal, the remaining part is also equal, that is BE and CE are equal. So using 5 and 6, we can conclude that the segments of one chord equal to corresponding segments of the other chord. Question number 3. If two equal chords of the circle intersect within the circle, prove that the line joining the point of intersection to the center make equal angle with the chords. That means they are intersecting at E, and the line joining the point of intersection to the center, OE, right, make equal angle with the chord. That means angle E equal to angle E. With the chords only, that angles are equal, we should prove. So given AB equal to CD, and also they intersect at E. To prove OEM, angle OEM equal to angle OEN. Construction OM perpendicular to AB, ON perpendicular to CD. Proof. AB equal to CD. So what you can say about OM and ON? OM equal to ON. Equation number 1, because the chords, equal chords are equidistant from the center. So in triangle OME and triangle ONE, angle M equal to angle N equal to 90 degree by construction. Okay. OE equal to OE common, and OM equal to ON proved in 1. Therefore, triangle OME is congruent to triangle ONE. Which criteria? 90 degree hypotenuse and the side. So which criteria it is? RHS only. So I'll make it O here and triangle sign here ONE. Here criteria is RHS. Okay, I'll write once again. Triangle OME congruent to ONE by RHS. Easy only now compared to the last question. Now from this what we can write? Angle MEO equal to angle NEO. CPC. Hence proved. So only one point we have to remember, equal chords are equidistant from the center. So first equal side, the second equal side, and 90 degree both are by congruent by RHS criteria. So this angle, whatever we need, that are equal by CPCT, hence proved. If a line intersects two concentric circles with the center O and intersecting at how many points A, B, C, D? Prove that the chord are, prove that AB and CD are equal. So what is the question? If a line intersects two concentric circles with the same center, with the center O and at ABCD only, we have to prove AB and CD are equal. For this construction is required, we have to draw a perpendicular line here. So I'll write here OM perpendicular to this chord AD. The longer length will take. So given concentric circle with the center O. To prove AB equal to CT, construction OM perpendicular to AD. Okay. Now we know that when a perpendicular drawn from the center bisects the chord only. So proof perpendicular from the center of the circle bisects the chord. Therefore, AM equal to DM. Similarly, BM equal to CM. Equation 1 and 2. 1 minus 2 gives AM minus BM equal to DM minus CM. So AB equal to CD. Hence proved. Only one concept we have to remember here. The perpendicular drawn from the center bisects the chord only. So first we are taking the chord AD bisecting at M. So AM equal to DM. Now second we are taking the chord which one? BC as the chord. So BM equal to CM. Just to subtract this one, we will get the result AB equal to CD. So with this today's class I am winding up. Thank you.